So this is the first chapter of Subject Engineering Max 3 BE 21503, which is about coordinate system. Okay, so the coordinate system, they are an ordered set of values which specify a location relative to some origin. And the order of the coordinate is important in this case, and there are a variety of coordinate systems exist. So the coordinate system is a method for us to identify the location of a point at a particular system. So we will use this coordinate system to indicate the location and position of a point and do further arithmetic operation on this point. So we have 2D and 3D coordinate system. 2D is two-dimensional, 3D is three-dimensional. Okay, so a 2D coordinate system is used to specify all location in 2D space. So normally in 2D coordinate systems, okay, we will have two axes, okay, something like this. Okay, I think you are familiar with this. So normally we will have two axes in 2D coordinate system. We have axis X and we have axis Y here. Okay, so this is a 2D coordinate systems. And we when talking about the 3D coordinate system, of course we will talk about additional one more axis, which is the axis Z. So normally you will draw the axis something like this. So this one is the z-axis, okay, the z-axis, and this one is the y-axis, and this one is the x-axis. Okay, so you just extend one more axis in 3D coordinate system. Okay, so let's look at the first type of coordinate system, which is the Cartesian coordinate system. So for Cartesian coordinate system, okay, sometimes we call it as a rectangular coordinate system. Okay, so actually we have two types of coordinate system in two-dimensional coordinate, which are Cartesian and also polar. Okay, so the first one will be the Cartesian coordinate. Okay, so this is the 2D Cartesian coordinate system. So for 2D Cartesian coordinate system, for every particular location or position, we will represent it with two coordinates. Okay, the first is the x coordinate and the second is the y coordinate. Okay, this is very basic. I think you learned it before. So when you specify a number for the x coordinate, okay, for example in this case it is 3, so you just refer to your 2D axis. Okay, x is here, y is here. When you specify the x to be 3, so you just extend a line from 3 and then you refer to the second value, okay, which is the y coordinate. In this case it is 4, so you extend another line from the 4, okay, located at the y-axis, and the intersection point between these two lines, okay, is the position or location of point 3, 4. Okay, so this is the same as the P2, okay, where you extend -1, okay, from the x-axis and -3 from the y-axis. Then you can locate the point at this position. Okay, so this is 2D Cartesian coordinate system. Okay, so this one you can read it yourself. Okay, it's like what I explained just now. Okay, they are all the set because they are all the metal. Okay, so x coordinate come first and then followed by the y coordinate. Okay, so this is all the explanation. So we proceed to the second coordinate system, okay, which is under the category of 2D coordinate system. It is polar coordinate system. So for polar coordinate system, it is a bit different, okay, because we use different notations compared to the Cartesian coordinate system. So here there is no more x and y, but we will replace the x and y with r, small letter r, and theta. Okay, this is a symbol. Okay, usually we use it to represent angle and we call it theta, Theta. Okay, so what is the meaning of R? R normally represent the length, okay, the length, okay, how long is this line, for example, okay, represent the length or magnitude of this line, and the theta represent the angle that started from the x-axis. Okay, if you look at this diagram, the angle of the theta is always started from the x-axis, so you have to remember this one. Okay, so R represent the magnitude and the theta represent an angle which is started from the x-axis. So the angle, when the angle is positive, it will oriented in the counterclockwise direction, okay, in this direction, okay, when the theta is positive. So this is your 2D coordinate system. Okay, so your 2D coordinate system, like I mentioned just now, for 2D coordinate system, you will have two axes, which is axis x here and y is here. So for the whole area of the 2D coordinate, we will split it into different sections, and we name different sections by using different names. For example, for these sections, we name it as quadrant 1, where the x value and y value, they are both positive. And for quadrant 2, one is negative, positive, and this is quadrant 3 and quadrant 4. Okay, so this is some examples on how we plot the points where their polar coordinate are given. Okay, for example, this one, okay, this is 1 and 5 pi over 4. So for this one, excuse me, okay, so because this is polar coordinate, right? So for polar coordinate, you have a r and you have a theta, okay, to represent the angle. So this one basically represent the length, the magnitude, okay. So this one is your x-axis, okay, and this is the origin. So first of all, you can actually indicate a line, okay, indicate a line, okay, and this one, assume it, okay, the magnitude is equals to 1, okay. After that, you turn it for 5 pi over 4. So for 5 pi over 4, okay, you turn it in this way, okay, in the anti-clockwise direction, because the angle is positive. So you turn this red line, okay, for 5 pi over 4. Okay, so you will reach this point, okay, and the length is still 1. So this one will be the coordinate for this point, okay. Similar for this one, this is also the r, this is the pi, okay. So the magnitude will be r. After that, you turn it for 3 pi, okay. And for this one, it's also 2, but you turn it in the other direction, because the angle is negative. When you found that there is a negative symbol in front of the angle, you have to turn it the other way around. This one we turn it in the anti-clockwise direction, okay, anti-clockwise direction. Because of this negative, we have to turn it in the clockwise direction, okay. So this one will be the angle. And for this one, for negative 3, if you found that you have been given a negative 3, the magnitude or the length of the r is negative 3, okay, you have to move it in the other direction. So for example, this one is 3 pi over 4, okay, 3 pi over 4, suppose you will move in this way, right, because the angle is positive. And because of the value of the negative, you have to mirror it, okay, in the other direction. So this one will be the actual direction for this negative 3 and 3 pi over 4. And maybe you are not used to the angle which is represented in pi. So for your information, when the angle is represented in unit of pi, they are actually in the unit of radian. Okay, we are used to deal with the angle in the unit of degree, but we can convert in between radian and degree. Okay, so for example, if you want to find the angle which is in the unit of radian, you take the degrees angle and multiply it with pi, divide 180. Okay, so on the other hand, if you want to find your angle in the unit of degree, you take your radian and multiply it with 180. For example, like this one, this is 5 pi over 4, right? So 5 pi over 4, if you want to change it to degree, okay, you want to imagine what is the degree of this thing. So it will be 5 pi over 4 multiply 180 and divide by pi. Okay, so this one will be 90 and 45. So when 45 times 5, it will be 225. So this one will be the angle in the unit of degree. Okay, same as this one, and this one as well. So in this subject, you are mostly deal with the angle in the unit of radian. If you found there is a pi symbol here, most of it they are radian. But if we want to indicate a position or location in the unit of degree, normally, for example, like this one, we will put an angle, symbol for the unit of degree. Okay, if the angle is represented in this way, it means that it is in the degree unit. Okay, so don't confuse. Okay, so this one I mentioned before. When the angle is positive, you measure it, okay, from the counterclockwise directions, and negative, it will be the clockwise directions. Okay, next, we will move on to the conversion between Cartesian and polar. Okay, so if you put both Cartesian and polar coordinate in the same figure, so things will be like this. Okay, this one is your x-axis, this one is your y-axis. So this is the point. It's okay, if you want to represent this point by using the Cartesian, you will represent it with notation x and y. But if you want to represent it with polar coordinate, you will represent it with r and also theta. So now we can perform conversion in between these two coordinate systems. Okay, so the relationship between these two is this one. Okay, if you want to find the value of r, okay, you can take the x squared plus y squared. Okay, so r will be square root of it. Okay, if you want to find the r, it will be x squared plus y squared and then square root. Okay, and for the angle of theta, you can find by using this way or the other trigonometry formulation. Okay, you can relate it. So next will be the conversion from polar to Cartesian. Okay, so if you want to find the value of y, you take the r. Okay, this is your r, multiply with the sine theta. And the x will be, you take the r and multiply with the cos theta. Okay, so this is all about the 2D coordinate system. It is very easy, right? I think you deal with it before. And next we move on to the 3D Cartesian coordinate. So for 3D Cartesian coordinate, like I mentioned just now, you will have an additional axis, which is the axis z here. So just now we deal with axis y, we deal with axis x, and so now you have one more axis z. So for 3D coordinates, we have three. Okay, we have three types of coordinate, and the first one is the rectangular coordinate, second one is the cylindrical, and the third one is the spherical. We will look at it one by one. Let's move on to the first one, which is the rectangular coordinate, or sometimes we call it as the Cartesian coordinate. Okay, so this is the diagram to give you some illustrations on a point, okay, which is located at in a space which is represented by 3D Cartesian coordinate. So this coordinate will be represented by three parameters, x, y, and z. Z will represent the height, okay, when you extend in the z-axis direction. Okay, so and for the cylindrical, okay, this is about the Cartesian, very easy. Okay, and for the cylindrical, okay, it is actually extension from the polar. okay, polar coordinate. Okay, if you look at this part, okay, this is actually the polar coordinate that you have learned just now. So you have the r, you have the theta. Okay, so for cylindrical, you will extend it upward in the z directions. So you will have r, theta, and also the z. So these are the parameters, are the notations that we will use in the cylindrical coordinates. Okay, so how to represent a 3D point in cylindrical coordinate? Okay, first of all, okay, we use the technique that we apply in the polar coordinate. Okay, we move the r in certain in certain angle. Okay, started from the x-axis. Okay, so after that, we create a circle. Okay, we create a circle. So this one should be here. Okay, we create a circle, okay, to represent the shape of the circle. After that, we extend it up. Okay, so this one will be the final coordinate of a point, which is represented by cylindrical coordinate. Okay, so next one, okay, is representing the a point by using the spherical coordinate. Okay, we'll move on to the spherical coordinate. For example, now if you have a point here, okay, so we want to represent this point by using a spherical coordinate. So what we do is we measure its distance r from the origin. Okay, this is the coordinate and we measure its distance. Okay, so connect the origin with the point, with the position of the point. So we name this parameter as r. So this one will be the r. Okay, so next we have to find a way to describe its location on the sphere. So how we do it? So we will use the method very similar to the method we use to measure the longitude and altitude on the surface on the earth. So first of all, we measure the longitude. What is longitude? Okay, longitude is this one. So we find the great circles that goes through the North Pole and the South Pole. So imagine this one is the Earth and this is the North Pole and this is the South Pole. So you will make a circle, okay, from the north to the south. Okay, so this is the longitude. So we measure the angle starting at the North Pole. Okay, so now this is the point that we want, right? So we start to measure the angle from the z-axis. So this angle will be represented by notation phi. Okay, phi, P-H-I, phi. And the range for this angle is from 0 until pi, which is 180 degrees. Okay, so this angle will it will start from here until here. Okay, for 180 degrees. Okay, so this is the first notations that we use in the spherical coordinate. Okay, so next we move on to the other. Okay, we define a latitude. Okay, a latitude, this is the black line, is the latitude. Okay, latitude that touch the point. Okay, next we extend it down. Okay, we extend it down. Okay, we extend it down into the XY plane. And next, we find the angle. Okay, the angle from x-axis until it touch the projection here will be the angle of theta. And this theta is range is from 0 until 360 degrees. So this one is actually very similar to the polar coordinate. Okay, so this angle we call it as the theta. Okay, theta. So finally we can represent a point by using spherical coordinate. R is the direct distance, theta is the angles here, right? Just now we extend from here to here. That's the angle. This is the theta. and the phi will be from here to here. Okay, so this one will be your phi. Okay, so I think you got some idea about what is Cartesian, what is spherical, what is cylindrical. Now we are going to conduct conversion in between these Cartesian, in between these coordinate system. Okay, so for example, the first one, how we going to convert from Cartesian to cylindrical? So this one will be the formula. Okay, from this one is for cylindrical to Cartesian, and this one is actually from Cartesian to cylindrical. Okay, you use this formula. Okay, so this formula you have to remember it because it will be given in the exam. Okay, so you have to remember this one. Sorry, this one shouldn't be phi. Okay, this one should be theta. Okay. Okay. And from Cartesian to spherical, okay, this is the formulations. Okay, how to convert from the Cartesian XYZ and convert it to the R, phi, and theta. Okay, this is their relationship. Okay, and from spherical to Cartesian. Okay, spherical to Cartesian. So this will be the formula. And lastly will be the spherical to cylindrical. Okay, so this will be the formula. Okay, so you have to remember all these formula. So this is all about the first chapter about the 2D and also the 3D coordinate systems. Okay, now let's try to have some exercise for this chapter. So this is files that you can get it from the tutorial folder. So let's look at question 1. So illustrate the location of this point using 2D rectangular coordinate system. So we will try all. Let's say we try E, question E, 1E. Okay, so let's move on to E. Okay, question 1E. Okay, so we have to locate this point, which is 8 and -4. Okay, -4. Okay, in Cartesian coordinate. Okay, so when you look at these coordinate, there are only two of them, right? X and Y, Cartesian. So it is a 2D coordinate. So you have to construct a 2D coordinate. Okay, 2D coordinate. So this one is your y-axis and this one is your x-axis. So look at the first point, first number. It actually represents the value on the x-axis, so it should be 8. For example, this is your 8. Okay, and the second number represents the value on axis y, okay, which is -4. So -4 is here, for example. So we extend the line and we extend the line here, so the intersection point will be here. So this one will be your coordinate 8 and -4. Okay, very easy, right? So we try next question. Okay, question 2. Okay, question 2. So we have to illustrate the location of this point, but this time you have to use the polar coordinate. Okay, polar coordinate. So let's try one example. Okay, this one D. Okay, 2D. Okay, 6, 2, 6, 5. Okay, when you see this symbol, it means that the angle they are represented in unit of degree. Okay, so we have 2D. Okay, the coordinate is 6, 265, right? 265 degree, right? 265, huh? Okay, so same again, you construct your 2D coordinate system. So you label again y and also the x. Okay, so the first number actually represents the value of the r, if you remember, and the second value represent the value for the theta, the angle. Okay, so 6 is the magnitude. For example, this one is your 6. Okay, 6 here. You have a line. Okay, this is your line, and its length is 6 units. And you have to move this line in the anti-clockwise direction for 265 degrees. So this one will be 90, 180, and 270. So maybe 265 is somewhere here. Okay, so you move this line here. So you move this line. This might be your line. Okay, this might be your line. Okay, 6 units. Okay, so the length, okay, is still 6 units, and the angle is 265 degrees. And this one will be your position for point 6 and 265. Right, it's very easy. Now let's move on to the third example. Okay, so in the third question you have to convert, okay, the coordinate in question 1, okay, to its associated coordinate in 2D polar coordinate. It means currently question 1, all these coordinates, they are represented in Cartesian coordinate, and you have to convert it into polar coordinate. So let's try to use back the example, okay, that we have just now, okay, which is this one, right? So we try 3e. Okay, we try 3e. So we try 3e. Okay, the point is 8 and -4. Okay, you have to convert it to polar coordinate, okay, which will be represented by r and its value theta. So you can refer back to the slide that we have just now about the conversions. Okay, so just this is Cartesian to polar, right? So you have to use these two equations. Okay, so r will be equals to x squared plus y squared and square root. This one is one of the formula, and the other formula is this one, right? Okay, theta equals to arctangent y over x right. So what you have to do is to just replace the value into the equations. So 8 squared plus y squared. So your y is -4. Okay, don't forget about the negative, and then you can calculate for its value. The value will be square root 80. You can leave your answer in this way, or you press the calculator and get its value equals to 8.94. Okay, how about this one? So this one will be the arctangent, and the y is -4 over 8. So you will get your angle equals to -26.57, and this is degree. Okay, whether the answer is degree or radian, it depends on the setting of your calculator. You can set your calculator to display the angle in unit of degree or radian. You have to set it. So in my calculator, I set it to be degree. So this one, of course, will be a degree value. Okay, so this is not the end of the conversion or the solutions. Normally, you have to check whether the answer, okay, that you calculate is correct or not. How to check? Okay, so we have to draw back the point. Okay, we draw back the point. So we have the y, we have the x. So just now we have 8 and negative 4 here, right? Okay, now look at the answer that we have now here. Okay, so the r is equals to 8.94 and the angle, the theta, is negative 26. Okay, so it is possible. Okay, so just imagine this one is your 8.94 and the angle is negative, right? So negative means that it is in the clockwise directions. Okay, clockwise directions. So 26.57 degree. So both answer, they are located in the same quadrant. This is quadrant 1, if you remember. Okay, quadrant. What is quadrant? Okay, here, right? We have 1, 2, 3, 4. So for both coordinate, they are located in the same quadrant, which is quadrant 4. Okay, so that means that the answer is correct. Okay, you have done your conversion correctly. So finally, okay, you have to write your answer 8.94 and comma negative 26.57 degree. Okay, this one will be your answer. So this is how you apply the formula to convert from Cartesian coordinate to polar coordinate. Okay, we try next questions. Okay, question 4. Okay, the other way around, where we have to convert all the points in question 2 to rectangular coordinate. So just now we tried this D, right? So for question 4, we'll try back this one, which is the 4D. So we try 4D. So for D you have 6 and 2, 6, 5, right? Okay, so you have to convert it to Cartesian or rectangular coordinate, which is represented by is x and y. So look at your notes. Okay, what formula that you should use? Okay, so this one will be the formula. Okay, so you use y equals to r sine theta and x equals to r cos theta. Okay, so your r is 6 sine theta. So your theta is 265. Okay, so here before you use your calculator, you have to make sure that your calculator setting is in the degree, because now your angle is in the unit of degree. You have to make sure that your calculator is in the setting of degree as well. You will get your answer is negative 5.98. Okay, how about the x? 6 cos 265, so equals to negative 0.523. 523. Okay, 523. Okay, again you have to double check whether you have done the conversion correctly or not. Okay, so you draw the axis. So just now for the 6 265, okay, it's here, right? Somewhere here is your y and this one is your x. Okay, so your x is negative. Okay, negative is correct. Okay, negative, and your y is also negative. Okay, so you have done the calculation correctly. Okay, So this one will be the position of the point which is located in quadrant 3. Both before and after conversion, they are all located in quadrant 3. So we have done the conversion correctly, and you write your answer. Okay, so this is about the 2D, okay, how you locate the point by using different coordinate system and how you do the conversions. Okay, next we move on to the 3D coordinate system. Okay, so for 3D coordinate system, question 5, let's say we try this one. 5, -2, -2. So this is question 5, 5C, okay. Question 5C, 5, -2, and -2. Okay, how to locate the point. Okay, so this is 3D coordinate. It means that you will have 3 axes. You have axis Z, axis Y, and also axis X. Okay. This one is the default position of all the axes. You can change it, okay, but you must indicate it. So this one will be the X, Y, and Z. Okay, so look at the first one. It represents the value on axis X. Second one will be Y, and the third one will be Z. Okay, so let's say this is your 5. Okay, 5. Okay, refer to axis Y. Okay, the value is -2. Okay, so when it is -2, okay, it means that you have to extend the line. Okay, let me extend the line first. Okay, so I'll move this one back. Okay, so where is -2? Let's say it is here. -2 is here. Okay, now we continue to extend the line. Okay, we extend the line. -2, we extend it. And for the and for 5, we extend it as well. Okay, so this one will be the point. Okay, next we move in the negative Z direction because the value is -2. So we have to move down for 2 units. Okay, this thing we move down 2 units. Okay, for example, this is 2 units. Okay, 2 units. So this one will be your final point. Okay, final point for this coordinate 5, -2, and -2. Okay, this is how you locate a point using 3D Cartesian coordinate. Okay, let's move on. Okay, to cylindrical coordinate. Let's try this one. 6C. Okay, 6C. Okay, we move on to 6C. Which is five, and -5. Okay, this is this is cylindrical coordinate. So this one will represent R, this one represent theta, and this one represent Z. Okay, so we construct the axis. will still label it even though we didn't use the x, y, z. Okay, so for this one it is 5. Okay, 5. So from here you might want to draw a line. Okay, 5 unit length. Okay, 5. After that you turn it for pi radian. What is pi? Okay, pi is equals to 180 degree. So when it's 180 degrees, so here you might need to extend your axis. Okay, you need to extend it. So remember, when you start the angle, it is always from the x-axis. The angle is positive, so you will move in the anti-clockwise direction until you touch the angle pi. Okay, so now your line is here. Okay, you have moved your line here. Okay, last one is the z. So now you have to move in the z-axis directions, either upward or downward. So for this case, you have to move it downward. So you have to move it downward. For how many units? 5 units. So this one will be your final point. 5, pi, and -5. So it is very important for you to show me the steps. Okay, for example, you label this one 5 unit and you move this one for angle pi, and then you move down, because sometimes it is very hard to imagine by using 2D diagram, but we have to imagine it 3D. So I will judge whether your answer is correct or not based on your steps. Okay, so if I look at this step or this step, I know that you know how to locate this point. So this is question 6C, how we locate a point using cylindrical coordinate system. Okay, now let's move on to the question 7. Okay, we will locate the point using spherical coordinate system. We will try these questions. 7C. 8, and then okay, so this one is the coordinate given by using spherical coordinate system. So for spherical coordinate system, this one will be your r, this one will be your theta, and this one will be your this one will be your phi. Yeah? Okay, we construct the 3D axis. Okay, so this one is the 3D axis. So we refer to the R first. Okay, the R is 8 units. So you started from the origin and you make a line and assume here the magnitude is 8. After that, you have to move, okay, for pi over 3. Any idea what is pi over 3? So just on the pi is 180. So when you divide 3, it will be 60. Okay, so you have to move angle 60 maybe somewhere here. Okay, here. Okay, so 60 is from here until here. okay, in the anti-clockwise directions. So this one will be pi over 3. And now you have moved your length here. After that, what you have to do? Okay, so now the phi is 120. Phi is the angle that we calculate or start from the z-axis. So if we move from this line, the z-axis, until this line, the angle is 90 degrees, right? So currently this line is located at the position of 90 degrees, but the question wants this line to be in the position of 120, which means that you need to further move down. Okay, you need to move down further. You need to move down further. Okay, so can I change the color? Maybe I change this one. Okay, you need to further move down. And this line you move down, so the angle will be from here until here, which its value is 120 degree. Okay, so this is a 2D diagram, so you have to show the steps. Then only I know. Okay, first of all you have this 8, after that you move to here, okay, and then after that you move down. Okay, I can see your steps. Okay, so here will be the final position of this point, 8 pi over 3 and then 120 degree. So this is how you locate a point by using spherical coordinate system. Okay, we move on to the next example. Okay, they are all about conversions, so maybe I will try a few on it. Maybe question 8. Okay, so question 8, we have to convert it to cylindrical coordinate system. Okay, so just now question 5, what question we try? Okay, we try C, right? 5 to 2 and 5 negative 2 negative 2. We have to convert it to cylindrical. Okay, so let's look at C. Okay, this one should be at C, right? So you have 5, negative 2, negative 2. Okay, you have to convert it to cylindrical, and you should remember cylindrical, you have R, you have theta, and you have Z. And this one is X, Y, Z. So what are the equations that we have to use? So you have to refer back to your notes. Okay. So Cartesian, cylindrical. Okay, Cartesian to cylindrical. So this one will be the formula that you have to use. Okay. So R equal to x squared plus y squared square root, and this one will be arctangent y over x, and z will be same as z as well. You don't need to do anything. Okay, so for this one, let's do the calculations. So it will be 5 square plus negative 2 square it will be square root 29. How about the theta? So your y is equals to negative 2, your x equals to 5. It will be negative 21.8 degree, and your z will be the same, which is negative 2. Okay, so you have to double check again whether it is correct or not. So you have to draw these coordinate, right? When I mention you have to, I mention you have to double check. Okay, so this color. Okay, first of all, the magnitude is square root 29. Okay, square root 29. So from here, we'll construct a line, and maybe here it will be square root 29, and the angle is negative 21.8. Okay, negative 21.8. Which means that I have to extend my axis y. Okay. Oh my god. Okay, extend it around negative 21. Negative 21, it might be somewhere here. Right. Okay. So because the angle is negative, so I move in the clockwise directions, which is 21.8. After that, what you have to do, we have to extend in the z direction, which is negative 2. So you extend it in negative z directions. So this one should be your final point, right? Okay. So you have to refer, you have to look at this position, and then you compare it with the answer that we got just now. We got 5C, right? It's here, right? Is it in the same locations? Yes, they are in the same locations. So you can justify that your conversion is correct. This is how you actually double check your answer, whether it is correct or not. You have to remember, you have to do it every time, huh? So I always ask you to double check whether your answer is correct or not. Why? We'll show you one example, okay, which is not here, which is not from your tutorial. Okay. So now if I give you a Cartesian coordinate and I ask you to convert it to cylindrical, which means that you have r, you have theta, and you have z. So you can use the formula that we have just now, am I right? So you perform the calculation as usual. Okay, so this one will be negative 2, negative 3, and square it. You will get square root 13, and the theta is equals to arctangents, negative 3, negative 2. So you will get 3, 1, and z, it will be 5. Okay, so you need to double check the answer, right? So let's double check the answer. So this is z, and this is y, and this is x. Okay, let's look at this one first, huh? Okay, so first of all, we plot this one, square root 13. Okay, so square root 13 is here, and move in the positive angle 56. Okay, so you will move in the clockwise directions, maybe here. Okay, here I shorten it, here a bit. Right. Okay, 56 something. So after that, you move up another 5 units. Right. This is what you will do. Okay. So this should be the position, final position of the point. Okay, after you have done the conversion. But let's look at what is the actual position of this point. Negative 2, negative 3, and 5. Okay. So I might want to change. Okay, so for negative 2, negative 3, and 5. Okay, negative 2 is behind, right? So I have to extend my line. Okay, I use different colors to indicate its difference. Okay. Okay, I use the other line also. Okay. So just now I have negative 2, right? So x negative 2 maybe is here, and y negative 3 maybe is here. Okay. Then I extend my line, right? And I extend my line. So this one is the intersection point. Alright, negative 2, negative 3. So what I will do next is I move upward for 5 units, right? Okay, because the z is 5. So this will be the original position of the point. But see, after I have done the conversions, the point is located at different quadrant. Okay, so this is the importance that we double check. Okay, is there any calculation wrong? No, the calculation is correct. So what's wrong? What make the difference? So actually, the angle that we want is this one. No, it's this one. So the 56.31 is actually the angle from here to here. Okay, 56.31. Okay, it's not here. Okay, this happened. Okay, you will get the same answer, 56.31, when you divide negative 3 with negative 2 and 3 over 2. Okay, because these two things they will cancel out, so you will get the same thing as 3 over 2. When this is 3 over 2, the angle will be here. But the actual angle is actually happen when the x and y, they are both negative. So it should be here. So the correct answer and correct angle will be this one, 8 another 180 degrees. Okay, if you refer to this one, if this one is 56.31, you want to find the angle, you should start from the x-axis. Okay, you will move another 180 degrees. So the final angle that should be used to represent this point should be 180 plus 56.31, okay, which is 236.31. That's why if you leave your answer in this way, you will not get full marks, okay, because they are wrong, right? You have to top up another 180 degrees. So finally, you have to write your answer in this way. So it should be square root 13, okay, and 236.31, and then degree and 5. So this will be your final answer. Okay, so this is the importance that we double check the answer by using the diagram. Okay, so there are actually many more exercise here, how to convert in between rectangular, spherical, cylindrical, and so on. So I want you to complete, okay, the highlighted questions. So here there are questions that has been highlighted. Okay, so I want you to complete all these questions at home and then submit the answer, okay, in the next tutorial class. So this one will be personal assignment or personal tutorial. So each of you have to submit one set. Okay, so submit it when we meet next week. Okay, when we meet next week in the tutorial class. Okay, so that's all for the chapter 1.